Hello everyone, welcome back to the channel. So in the previous session, we have successfully completed one of the important chapter of a physical section, or I can say the last chapter, surface chemistry. There we have discussed each and every concept. Well, now I'm going to discuss the one of the important chapter of a class tall, that is D and F block elements. So it belongs to the inorganic section. Is also one of the important chapter, I can say major chapter from inorganic section, and is going to have various important concepts which are very important for even advanced level entrance examinations. Well, not wasting much time, we'll switch over to the concept that is introduction to D and F block elements. Well, now, so first we are going to switch over a concept regarding or which is related to D block elements. Okay, first we complete the D block element, thereafter we switch over to F block elements. Well, now I am going for introduction to D block elements, or I can say D as well as F block elements. Well, before going for the introduction part, well, when we look around, okay, when we look around, that is when we look over the around the nature, yes, what we observe different colors in the universe, right? We observe different colors. Now, if I consider colorless substance, colorless means what it is? White, right? Yes or no? Colorless ಅಂದ್ರೆ ಏನು ಹೇಳ್ತೀವಿ ನಾವು? White ಅಂತ ಹೇಳ್ತೀವಿ. So, when you think of white, yes, white appears good, but are we satisfied with the only white color? Yes, what is the answer? Not at all, right? So we are not going to satisfy with white color always, right? Yes, colorless things is nothing but it is a white one. It looks good, but we are not at all satisfied all the time. Then what? When you look around, or I can say we observe around, what we observe different colors. Then you might get a question in our mind, right? So what is that question? Say, have thought about why the nature is going to have, or how this nature is going to have, are going to appear different in color. Why it is so colorful? Yes, is one of the important question, or pretty good question here, to understand the meaning why we are getting different colors, or why there are various colors in the universe, or why this nature is going to have wonderful colors. It can be understood when we observe carefully, when we go through the nature of elements and their behavior of D and F block elements. Okay, if you study the D and F block elements, if you study the properties, that is both physical as well as chemical properties, or you can say behavior of these elements, we can answer for such questions. Why the nature is so pretty or so colorful means it is one. Okay, it's because of the properties exhibited by the D and F block elements present in the universe, or you can say nature. Well, now if you consider D block elements, yes, what are D block elements? If you want to define it, yes, there are various ways. There are various ways to define D block elements. So we are saying we have many definitions for D block element. Yes, in the previous sessions, in the sense in the last year, in the first PU, we also to come across S block and P block elements. Then in the second PU, we are studying the D block elements. So if we wish to define it, yes, there are various ways to define the D block element. Well, we look for the definitions. One of the way to define D block element is the elements in which differentiating electron. So what I'm saying, the elements in which differentiating electron. Yes, what is this differentiating electron? The differentiating electron is nothing but the last electron. Okay, last electron is called differentiating electron. The elements in which differentiating electron enters into n minus 1 d subshell. So please remember one of the way to define d block elements. So how we are defining the elements in which differentiating electron enters into what? It enters into n minus 1 d subshell. The n minus 1 d subshell are called d block elements. So is one of the definition for d block element. So just repeat the definition. The elements in which differentiating electron enters into n minus 1 d subshell are called d block elements. Well, the another way to define the elements in which differentiating electron enters into which shell? Penultimate shell. So what is the shell here? Penultimate shell are called D block elements. So here the penultimate shell, again the penultimate shell is nothing but last but one, or I can say n minus 1th shell. N minus 1th shell is called penultimate shell. Okay, so how we can define the D block? Yes, the elements in which differentiating electron enters into penultimate shell are called, okay, penultimate shell of what? D orbitals is called a D block elements. So it is a one more definition. Then if we consider where we find these D block elements, yes, when you think of periodic table, all the elements are arranged in the form of, okay, groups and periods. Okay, all whatever the known elements, 118 elements are arranged in the form of groups and periods. So together constitutes a periodic table. Now here where we found these D block element means, yes, we know that when you think of P block, where they present on the extreme, I can say on the right side of a periodic table, on the extreme right side of a periodic table, P block elements are placed. And what about S block? On the extreme left side of a periodic table, on the left side S block elements are placed, and in between S and P block the D block elements are placed. Okay, then further if you consider the properties, S block elements are highly electropositive in nature. Okay, they are highly metallic in nature, they are going to show malleable ductile property, they show highly electropositive nature, they have a tendency to lose one or more electrons readily. Okay, is the one of the major property of a S block element. On the other hand, if you go for P block, yes, what is the property? Yes, P block elements are highly electronegative in nature, opposite to that of S block. Electronegative means, yes, they have a tendency of accepting one or more electrons readily. They are, therefore we say they are highly electronegative in nature. Now in between, what in between S and P block we have placed D block elements. So yes, D block, they are also called, okay, the alternative name for D block elements is the transition elements. Yes, why we are calling transition element means the properties of D block elements. Okay, when you compare the properties of D block elements with what S block and P block, the properties of a D block elements are transitory. You know, transitory as compared to, okay, electropositive nature of S block element and electronegative nature of a P block elements. Or else generally what I can say, the properties of a D block elements are transitory as compared to S and P block elements, hence they are named as transition elements. I repeat, why D block elements are transition elements, or why they called transition elements means the properties of a D block elements are transitory on comparison with the S block and P block elements, hence they are called transition elements. Okay, well, now when you think of periods, the group number 1 and 2 of a periodic table constitutes the, okay, S block. And when you think of P block, group number 13 to 18, group number 13 to 18 constitutes the P block. What is left here? Group number 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So what are the groups here? Group number 3 to 12. Group number 3 to 12 constitutes the transition elements of a periodic table, right? So if you think of position of a transition elements, where they are placed in between S and P block elements. What are the groups belongs? It belongs group number 3 to 12. The group number 3 to 12 of a periodic table, they constitutes the D block elements, or I can say transition elements. Okay, well, now further coming to the MCQ, the elements in which the last electron enters n minus 1d dash are called D block elements. So n minus 1d shell, options n minus 1d shell, subshell, okay, orbit, and next one orbital. Yes, what is the answer here? N minus 1d subshell, right? So second is the right choice. Well, the next one, D block elements are placed. Okay, D block elements are placed. If you think of position, where they placed, say first option between S and P block. Second option to the extreme left of a periodic table. Next option to the extreme right of a periodic table. Then next one, yes, what is the answer? Between S and P block elements. Okay, well, what are D block elements alternatively called? Means what are the other name for a D block elements? First we look for the options: transition elements, inner transition elements, okay, halogens, and metals. Yes, what is the answer? What is the other name for D block elements? The alternatively they are called transition elements. So even I said why they are called transition elements means, yes, the properties of a D block elements are transitory as compared to S and P block elements. So called transition elements. Okay, well, now if you want to know the D block elements particularly, so if you want to see only the D block elements, yes, just look at, say it constitutes the D block of a periodic table. So what are the elements includes here? Say atomic number at the top of each element. We have specified the atomic number. Say 21, right? 21 to 30. The next one 39 to 48. Next 71 to 80. Next one 103 to 112. Which means whatever the block I am specifying, it constitutes the D block of a periodic table, right? Say scandium first series, second series, third series, and fourth series. So what totally how many series are there? There are 4 series present in the D block. Okay, later we notice that what are those series and all. Well, now in the last 3 element, that is in the last 3 element, fourth series of a D block, and last 3 elements, 110 element is discovered, it is abbreviated as DS, and 111 it is also discovered, it is abbreviated as RG. Okay, yes, here what are these 110, 11 and 12 elements are? 110 DS, okay, it is abbreviated as DS and it is named as, okay, the stadium, and 111 Rontigium and 112 Copernicium. So these 3 elements again they are discovered, are added to the periodic table. Okay, well, now how many series are present? Yes, what I said, yes, there are 4 series, and what are those series? Yes, they are considered as a 3D, 4D, 5D, and a 6D series. Now we consider starting and last element, ending element of each series. Now 3D series, the starting elements is scandium. Okay, for 4D it is ytterbium, atomic number 39, 5D lanthanum 57, and 6D actinium, that is 89. Okay, and these elements belongs to which group? Third group of a periodic table, right? And on the other hand, we said the ending element, the last elements of each series. For 3D, what is the ending element? Zinc. Okay, Zn, atomic number 30. So 21 to 30 of a periodic table. Then 4D series, what is the last element? Cadmium. So 4D 39 to 48. Then yes, in the 5D series, first element lanthanum and the last element is mercury, and 5D and 6D series. Totally how many series? 4 series. Just we notice the starting as well as ending element. So starting elements scandium, ytterbium, lanthanum and actinium, and the ending elements zinc, cadmium, mercury and copernicium. Okay, well, now these ending elements belong to which group? They belong to 12th group of a periodic table. So remember here two things: starting elements belongs to third group of a periodic table, and the ending element belongs to the 12th group of a periodic table. Well, here, so after knowing the group number, and be ready with the electronic configurations. Yes, yes, we know the group number here, and we should be aware about the electronic configuration. Well, scandium, argon, we know the atomic number, right? So argon 4s krypton 5s to 4d1, lanthanum, xenon 6s to 5d1. Okay, actinium, radon 7s to 6d1, right? So 4s to 3d1, 5s to 4d1, 6s to 5d1, 7s to 61. These are the electronic configuration of a starting element. Similarly, if you look for electronic configuration of ending elements, zinc, cadmium, mercury, and copernicium. So for zinc, argon 4s to 3d10, cadmium 5s to 4d10, xenon 6s to 5d10, and copernicium radon 7s to 6d10. So when you look at their electronic configuration of starting and ending elements, so starting elements scandium, ytterbium, lanthanum, actinium, they are the first elements of respective series. So these are the first elements of a respective series, and the number of electrons in d subshell. When you look at the electronic configuration in all these, how many electrons are present in d subshell? There is one electron. Similarly, when you look at the number of electrons in the ending element, d orbital, number of electrons in d orbitals of ending element, how many electrons are present? There are 10 electrons. So what we can see here, so it can be interpreted that number of d electrons is variable. Number of d electrons is variable from what? From 1 to 10. So when you look at all the d block elements, they belongs to, okay, they belong to these four series, and here number of electrons varies from what? From 1 to 10. In which orbital? In the d orbital. Okay, now by analyzing all these, can you guess the general electronic configuration for d block elements? Yes, what I can say, ns1 to 2. What is the variable here? ns1 to 2 and n minus 1 d 1 to 10 means in s subshell there, what is the variation? That s subshell ns, okay, shell may have 1 or 2 electron, and what about subshell, that is n minus 1 d subshell, it may have 1 to 10 electrons. Overall, the general electronic configuration for d block elements is noble gas ns1 to 2, n minus 1 d 1 to 10. Okay, well, so general electronic configuration we found. What is that? Ns1 to 2, n minus 1 d 1 to 10. Now, if we concentrate on the first series, what is the first series? Scandium to zinc. So, here the first member is scandium and the last member is zinc. We observe that the differentiating electron enters into, that is the d electrons. That is the last electron enters into which subshell? It enters into d subshell. Which d? It is the 3d subshell. Therefore, the first series elements, okay, therefore this series is also called 3d series. We said there are four series in the d block. So in here, in the first series, the differentiating electrons enters into d orbitals, okay, as a 3d series elements. Well, say similarly, so then what do you consider the general electronic configuration? So for s1 to 2, 3d 1 to 10 is the general electronic configuration for 3d series elements. Similarly, if you go for the next series, what is the next series? That is ytterbium to cadmium, second series. Now let's have a look on the next series elements. So here in the next series, what we are analyzing, the differentiating electron enters into which orbital? That is 4d orbitals. Okay, 4d orbitals of a valence shell. Therefore, the second series is also called a 4d series. Second series of elements are called 4d series. Here a differentiating electron enters into 4d orbitals. Then what is the general electron configuration? 5s 1 to 2, 4d 1 to 10. Then go for the next series. What is the next series elements? Yes, lanthanum is the one element, then up to mercury. So here 6s to 5d1, right? What about differentiating electron? The differentiating electron enters into which orbital? 5d orbitals of a valence shell, right? So therefore it is called 5d series, or you can say the third series, right? And what about general electron configuration? It is 6s 1 to 2, okay, 6s 1 to 2 and 5d 1 to 10. And what is the last one? Actinium, then copernicium. When you look at the last series, what about differentiating electron? The differentiating electron enters into 6d orbitals, hence it is called 6d series, and its general electron configuration 7s 1 to 2 and 6d 1 to 10, right? So it is about general electron configuration of a d block elements. How many series? It has four series. First transition series is also called 3d series. Second transition series is also called 4d series. Third transition series is called 5d series, And the fourth transition series is called 6D series. Why we are calling these four series? Why they called 3D, 4D, 5D, 6D means since the differentiating electrons enters into 3D orbitals, 4D orbitals, 5D orbitals, and 6D orbitals respectively. Hence, they are named as 3D, 4D, 5D, and 6D series. Well, now coming to the MCQs, the first one, the general electron configuration of fifth period of a D block elements. Fifth period D block. So 4D 1 to 10, 5S 1 to 2, 3D 1 to 10, 4S 1 to 2, 5D 1 to 10, 6S 1 to 2. So fifth period, last option 6D 1 to 10, 7S 1 to 2. Fifth period ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. So fifth period 4D. So 4D 1 to 10, 5S 1 to 2 is the right choice. Well, the next one, what is the general electron configuration of D block elements? Yes, for D block elements, n minus 1, D1 to 2, 10, ns1 to 2. Next one, n minus 1, D1 to 10, ns2. Next option, n minus 1, D1 to 10, ns1. Fourth one, n minus 1, D1 to 10, ns0 to 2. Yes, what is the answer? N minus 1, D1 to 10, ns1 to 2 is the right choice. Next one, the general electron configuration of fourth period of a D block. Fourth period they are saying. Fourth period means third 3D series. 3D 1 to 10, 4S 1 to 2. Next option, 4D 1 to 10, 5S 1. Okay, 5D 1 to 10, 6S 1 to 2. Then 6D 1 to 10, 7S 1 to 2. Yes, what is the answer? 3D 1 to 10, 4S 1 to 2 is the right choice. Okay, the next one, how many elements do we have in each series of a D block element? Since we know that D subshell 5 orbitals 10 electrons means 10 elements. So each series is going to contain how many elements? 10 elements. So look at the options 2, 6, 10 and 14. Yes, what is the answer? 10 is the right choice. Well, so with this I'm going to conclude about this session. Again in the next session we look for other concept of a D and A block elements. Okay, thank you.